Hello everyone, let's solve this interesting question for today. If anyone is interested to solve this question, just pause this video, try to solve the question and comment down the answer. Before solving the question, the things we have to consider from the question is, the largest and the smallest semicircles are concentric. If two circles are concentric, then they both are sharing the common center. So find the shaded area. These are the things we have to consider for solving this question. Let's keep some points in this group of semicircle. As they said, the largest and the smallest semicircle are concentric. Let's start from there. Let's think the center of this semicircle as O. As the largest and the smallest semicircle is concentric, then O is the center for the largest semicircle also. Let's name the diameter as A, B, and name some more points here. Here it is C and here it is D, and name one more point here. Let's think it is E. Let's draw a radius for the largest semicircle. So draw a line from O to E, which is the radius for the largest semicircle. As the shaded part is little bit confusing, let's name some of these areas here. Let's name the area of the largest semicircle as A1 and the second largest as A2 and this one as A3 and the smallest as A4. Let's denote our final area as A, which is equals to A1 minus A2 plus A3 minus A4. This is the shaded part, right? Let's keep this aside. Now from the diagram we can write as O is the center of the largest semicircle, OA is equal to OB, right? And again, as O is the center for the smallest semicircle, we can also write OC is equals to OD, right? Here OA and OB are the radius for the largest semicircle. OC and OD are the radius of the smallest semicircle. Can I write one more equation like this? OC plus OB is equals to OD plus OA. Yes, OC and OD are equal and OB and OA are equal. I write this equation like this. Now OC plus OB we can write it as BC, right? And OD plus OA we can write it as DA. From this we came to know BC is equals to DA. Yes, BC and DA are the diameters of the semicircle A2 and A3. The areas of those both semicircles are equal. Area of A2 is equals to area of A3. From this, if we substitute A2 is equal to A3 in here, we can cancel A2 and A3, right? Now the area is remaining as A1 minus A4. So if you consider the radius of the largest semicircle as A and radius of the smallest semicircle as B, now we can write area formula as half times pi A square minus half times pi B square. If we take common half pi, it is half pi times A square minus B square. So our area is half pi times A square minus B square. Let's keep this equation aside. Now consider the triangle OEC. The triangle OC is right angle triangle with right angle at C. As it is the right angle triangle, we can apply the Pythagoras theorem, right? Here the Pythagoras theorem is CE square plus OC square is equals to OE square. Here it is given EC is equals to 2. 2 square plus we considered OC as B, right? The radius of the smallest semicircle, which is equals to OE square. OE is the radius of the largest semicircle, which we are treating as A. It is equals to A square. So 4 plus B square is equals to A square. If we send the B square to the right hand side, then it will become negative. 4 is equals to A square minus B square. If we substitute our finding A square minus B square is equal to 4, in our previous finding A is equals to half times pi times A square minus B square. So as we have equation which is area is equals to half times pi times A square minus B square. If we substitute A square minus B square is equal to 4, half times pi times 4. We can cancel this 2 times, right? So area of the shaded part is equals to 2 pi. If you find my explanation interesting, please like this video and subscribe to the channel. Thank you.